So in this video, we're going to look at adding potassium hydroxide or possibly sodium hydroxide to haloalkanes. So when we do that, there are two possible types of reactions that can occur, which would result in at least two different possible products. So the reagent can either be dissolved in water, which is KOH aqueous, or it can be dissolved in alcohol, which is KOH alcohol or ALC. So when KOH is aqueous or dissolved in water, we have a substitution reaction. And what that means is that in this case, the halogen substituent, the Cl, is going to be replaced by an OH or a hydroxy alcohol group. So it's going to change from a haloalkane to an alcohol. However, if we add the potassium hydroxide and it's dissolved in alcohol or KOH ALC, an elimination reaction occurs. So if we had a haloalkane, we are going to take the chlorine and we're going to remove the hydrogen from the adjacent carbon. And in this case, the adjacent carbon is the second carbon. So we're going to remove that hydrogen, that chlorine, to make a double bond or an alkene. And so we have two different types of products. We can either produce an alcohol or we can produce an alkene. The type of question that we have will look like this. Example, 2-fluoropropane is shown on the right. Here it is. It is reacted with potassium hydroxide. When it's reacted with potassium hydroxide, different products can be produced under different conditions. Give an account of the chemical reactions that occur to produce different products when potassium hydroxide is the reagent. Okay, so under different conditions is a phrase that means potassium hydroxide can either be dissolved in water or it can be dissolved in alcohol. Now, I always remember that if I'm using potassium hydroxide in alcohol, it will not produce the alcohol product. So it's going to produce the alkene. And when I have it dissolved in aqueous, then it's going to produce the alcohol. But the big thing I have in my mind is that, okay, it won't produce alcohol if it's dissolved in alcohol. Okay, that's just, and then I just sort of sort it out from there, knowing that it's going to produce an alkene or it's going to produce an alcohol. So I'm going to start off with the first one here. If we have the alcohol, it's not going to produce the alcohol, so it's going to produce the alkene. It's going to be an elimination reaction. I'm going to give the details here. So in this elimination reaction, the fluorine group and the hydrogen of an adjacent attached to an adjacent carbon is removed, producing a double bond. So 2-fluoropropane is symmetric, so it will always be removed from the first carbon, producing the propene molecule. Okay, so we have this reaction scheme here. So I guess if I want to do this fully, I'm going to say what is their conditions, or I'm going to write that it's potassium hydroxide and it's dissolved in alcohol. The type of reaction, I'm going to draw the reaction scheme and I'm going to name the product. So now we're going to talk about the other conditions or the other way that the reagent can be, and it can be dissolved aqueous. And remember, if it is aqueous, it's going to make the alcohol. So this is going to be a substitution reaction. In this case, the fluorine is going to be replaced by an OH group and it's going to produce the alcohol propan 2-ol. And this has all the information we need to get a full answer that might get an excellence grade. Hopefully this has been helpful. Hey, thanks for watching this video. Hopefully this has made you more confident with your chemistry. Don't forget to like, subscribe, or leave a comment about anything that you want to with this video or any questions you have. I'll see you later.